In this video, we are going to be looking at mirror formulas and their application. So let us take a look at this diagram with a mirror showing an object in front of it with the corresponding image. Now the distance, the ray that is incident on the mirror was reflected through F, and the ray that passes through F was reflected parallel to the principal axis to form the image. You can see there. Now the distance between the object and the mirror is U, which is the image, the object distance, and the distance between the image and the mirror is V, which is the image distance. Then F is the focal length of the mirror. It is the distance between F and P. So we define what F, U, and V are. F is the focal length of the mirror, and it is equal to radius of curvature divided by 2. U is the object distance from the mirror, while V is the image distance from the mirror. Now here is the mirror formula. The mirror formula is given as 1 over F. 1 divided by F is equal to 1 divided by V plus 1 divided by U. Let us take a look at the sign convention. When the mirror formula is used in practical problems, it is important to add a sign, a positive sign or a negative sign, to each of the distances depending on the sign rule or convention that is used. Two commonly used sign conventions are: 1, real is positive, which describes all real objects and images as positive and virtual images as negative. You can see with the arrow, inverted arrow, which gives the diagram for a real image, and the upright arrow, which use dashed lines to give the virtual images. 2, we have the new Cartesian, which describes distances on the left of a mirror as negative and the distances on the right of a mirror as positive. So you can see from here the dark vertical line represents a mirror, while the red line represents a number line. On the number line, the place where the mirror is placed is regarded as the 0 point, while all distances to the left are negative and all distances to the right are positive. Now let us differentiate between real is positive and the new Cartesian convention. 1. For real is positive, real objects and real images are considered to be at a positive distance from the mirror. For new Cartesian, distances measured to the right of the mirror are positive. 2. For real is positive, virtual images are at a negative distance from the object, while for the new Cartesian, distances measured to the left of the mirror are negative. 3. For real is positive, the focal length of a concave mirror is positive, while for new Cartesian, the focal length of a concave mirror is negative. 4. For real is positive, the focal length of a convex mirror is negative, while for new Cartesian, the focal length of a convex mirror is positive. So let us apply the mirror formula to solve some examples. An object is placed 10 cm in front of a concave mirror whose radius of curvature is 12 cm. Calculate the position, nature, and magnification of the image produced. Alright, for this problem, I'm going to be using the two conventions, real is positive and the new Cartesian. Now this is what I'm going to do. I'll start with the real is positive. Real images and objects will be given positive value. So for here, we have an object that is placed 10 cm in front of a concave mirror. So the object is going to be U is equal to 10 cm. So it's positive. The radius of curvature r is equal to 12 cm. So we can get the focal length from this data given. So the focal length is going to be equal to r divided by 2, which is equal to 12 divided by 2, which is equal to 6 cm. So the focal length is 6 cm because it is positive. Using 1 over f equals 1 over v plus 1 over u. Remember that this is the mirror formula. So using this, my focal length is, so we have to look for the nature and position of the image v. So I can make this the subject of the formula by doing this. 1 over v will be equal to 1 over f. Take this way, minus 1 over u. So 1 over v equals 1 over f. F is 6 minus 1 over u. My u is 10. So I'll get the LCM of this and this. The LCM of 6 and 10 is 30. So 30 divided by 6 is equal to 5. 5 times 1. So I have 5 minus 30 divided by 10. That is 2. 2 times 1. That's 2. So 1 over v equals 5 minus 2. Sorry, 30 divided by 10 is 3. 3 times 1. That is 3. So 5 minus 3 equals 2 over 30. So what we just do to take the inverse of this, from this we can say that v is equal to 30 divided by 2, which is equal to 15 cm. So you see that v is positive. Since v is positive, it therefore means that the image is real and it is on the same side as the object. So we can now calculate for the magnification. The linear magnification m is equal to v over u. That is image distance over object distance. So this is going to be equal to the image distance is 15 cm divided by the object distance, which is 10 cm. So we're going to impute that into this. So we'll get divided by 10 cm. This will cancel out this. So we have 1.5. So the linear magnification is 1.5. Now with the new Cartesian method, consider this number line with the 0 point here. All distances to the left are negative, while all distances to the right are positive. Now assuming our mirror is placed here, then we consider the distance to this side to be negative and this side to this side of the mirror to be what? Positive. Now from our rule, all distances to the left are taken to be negative and all distances to the right are taken to be what? Positive. Now this is a concave mirror. For a concave mirror, remember we said that the principal focus for a concave mirror using the new Cartesian rule is negative. So it means that my f is going to be equal to minus 12 divided by 2, which is going to minus 6 cm. Now, that is the principal focus, or the focal length rather. Then the object distance, this time around, is going to be equal to, now the object is placed in front of the mirror on this side. So this is going to be taken as negative. So the object is going to be minus 10 cm. Again, we are going to use the formula 1 over f equals 1 over v plus 1 over u. Now what are we looking for? 1 over v. So I'm going to make 1 over v the subject formula again. So I'm going to have 1 over v equals 1 over f minus 1 over u. I hope you understand what I did. I just took this one, transfer it this way, so it becomes 1 over f minus 1 over u equals 1 over v, which is the same as this. So I'll write this as 1 over v equals 1 over minus 6 plus, minus the negative sign here, minus 1 over minus 10. So minus 1 over minus. So when I work this out, I'm going to have 1 over v is equal to plus divided by minus is minus 1 over 6. So minus divided by plus, minus divided by minus becomes plus. So I have 1 over 6. So when I rearrange, I'm going to have 1 over v equals 1 over 10. So I arrange this, writing this 1 over 10 minus 1 over 6. So I'm going to have 1 over v equals, the LCM is 30. So I have 10 divided by 30 divided by 10, that's 3. 3 times 1, I have 3 minus 30 divided by 6, that's 5. 5 times 1, I have 5. So I have 1 over v is equal to 3 minus 5, that's minus 2 over 30. So we'll take the inverse. When we take the inverse, I'm going to have v equals 30 divided by minus 2, which is going to give me minus 15 cm. Now what you need to look at this is, since this image is negative, it means that the image is on the same side as the object. So for a concave mirror, once the image is on the same side as the object, the image is real. So this image here is real because it is on the same side as the object. Now we can calculate the magnification. In this case, the magnification is equal to v over u again. So that will be equal to minus 15 divided by, now our object distance is minus 10 divided by minus 10. So that will be 1.5 as it was with the previous result. So you see we have the same result. So example 2, an object is placed 15 cm in front of a convex mirror and an image is produced 5 cm behind the mirror. Calculate the focal length of the mirror. So using real is positive convention, I'm going to have my u to be equal to 15 cm. The object is positive in front of the mirror because I'm using real is positive. Then my v, image distance, is going to be negative, that's minus 5 cm, because irrespective of where you place the object for a convex lens, mirror rather, the image must always be formed behind the camera and it's going to be what? Always virtual. So this is going to be minus 5 because it is virtual. So we have to find the focal length. So to find the focal length, I'm going to use the formula, the mirror formula. 1 over f is equal to 1 over v plus 1 over u. So remember, we already know that this is our mirror formula. So I'm going to have 1 over f is equal to 1 over minus 15 plus 1 over minus 5 plus 1 over 15. And this is going to be equal to 1 over f equals, let me bring the positive value here, 1 over 15. Then I have this plus divided by minus is minus. So I'm going to have 1 over 5. So all I just do is to look for the LCM of 15 and 5. The LCM of 15 and 5 is 15. 15 divided by 15 is 1 times 1. That's going to be 1 minus 15 divided by 5 is 3 times 3. So I'm going to have 3. So 1 over f is equal to 1 minus 3. That's minus 2 over 15. Here we can say that just take the reciprocal of this and this, so f is going to be 15 divided by minus 2. So f is equal to 15 divided by minus 2 is going to be minus 7.5 cm. So this shows that the focal length of a convex mirror is negative. So have a negative value.
So example 3, a concave mirror of radius of curvature 20 cm produces an inverted image 3 times the size of the object placed on the perpendicular to the axis. Calculate the positions of the object and the image.
So the radius of curvature of the mirror R is equal to 20 cm. So the focal length of the mirror is going to be equal to 20 divided by 2. That is equal to 10 cm. Now we are told that the inverted image is 3 times the size of the object. So it means that the magnification is equal to V over U, which means that the magnification is 3 V all over U. So from here I'm going to make V the subject of the formula. So V is going to be equal to 3U. So by using the mirror formula, 1 over F equals 1 over V plus 1 over U. I'm going to have this. F is 10, is positive because it is a concave mirror. And I'm using real is positive convention. So I have 1 over 10 is equal to 1 over V is 3U plus 1 over U. From here, I'll take the LCM of 3U and U, and the LCM of 3U and U is 3U. So I have 3U. So 3U divided by 3U is 1 times 1. I have 1 plus 3U divided by U is 3 times 1. I have 3. So I have 1 over 10 is equal to 1 plus 3. That's 4 divided by 3U. So when I cross multiply, I'm going to have 3U is equal to 4 times 10, and U equals 4 times 10 is 40 divided by 3 centimeter. So this is going to give us an approximate value of 13.33 cm. Now that's the position of the image from the mirror, of the object from the mirror. Now the position of the object V equals 3U from the beginning here. So that will give us 3 times 40 over 3. And this will cancel out this. So we have 40 cm. So the position of the object is 13.3 cm. And that of the image is 40 cm in front of the concave mirror.
The distance between an erect image and the object is 30 cm. The image is twice as tall as the object. A. What is the object distance? B. Determine the radius of curvature. C. If the image is virtual, what type of mirror is used?
Now, there are two scenarios where you have an erect image. In a convex mirror, the image that is formed is always erect. But in a concave mirror, the image that is formed are always inverted,
except for one case where the object is placed between F, the principal focus, and P, the pole of the mirror. Now, if the magnification, if the image is higher than or is bigger than the object, then it means that the type of mirror that is used is the concave mirror. But if the object is diminished, the image is diminished, then it is a convex mirror that is. So this question directly points to the fact that a concave mirror was used to capture the image of this object. So if we now do this, now I'm going to draw a mirror, a concave mirror, and illustrate to you with a mirror. Now if you take a look at this diagram, this is an object here placed between F and P. You can see that the image is formed behind the mirror and the image is larger than the object. So what I want to do now is this. We are told that the distance between the erect image and the object is 30 cm. So I'm going to have 30 cm here, the distance between this and this. Now let's look at this. If the object distance from here to P is U, and the image distance from P to I is V, you realize that U plus V equals 30 cm. Now, they ask us to find the object distance. That's what they said we should. What is the object distance? So I'm going to do this the object distance. Since I'm looking for the object distance, I'm going to make V the subject of the formula. So from here, V is going to be equal to 30 minus U. And we are told that the image is twice as tall as the object. So the magnification N equals V over U. So since the image is twice as tall, it means that 2 equals image distance, that's 30 minus U divided by U. Now, there's something I want you to know. You notice that I did not include the negative sign on this. You don't need that when you're calculating magnification, except if you are using the new Cartesian rule. So we are using real is positive here. So when I cross multiply, I'm going to have 2U equals 30 minus U. When I bring this way, I'm going to have 2U plus U equals 30. So 3U equals 30 and U equals 30 divided by 3, which is equal to 10 cm. So the distance of the object is 10 cm. Then the B part, they said we should determine the radius of curvature of the mirror. So what do? We know that F equals R over 2, or radius of curvature is equal to 2F. So we are going to calculate the focal length. So the mirror formula is 1 over F equals 1 over V plus 1 over U. So we are going to calculate the value of V. So from here we can see that V is equal to 30 minus 10, because U is 10 cm. So that will give us 20 cm. So we're going to place this here. So I'm going to have 1 over F equals 1 over 20 plus 1 over 10. But remember that the image is virtual, it's on the other side. The image is virtual, it is on the other side. For that reason, so this is going to be minus 20. So I'm going to place minus 20 on this. So when I rearrange this, I'm going to have 1 over F, let me write the positive part first, equals 1 over 10. Then I'm going to have plus, okay, so I have plus here, plus divided by minus is minus. I'm going to have minus 1 over 20. So I'll take their LCM. 1 over F is equal to the LCM of 10 and 20 is 20. So
So I have 20 divided by 10 is 2, so I have 2. 20 divided by 20 divided by 20 is 1 times minus 1. I have this. So I have 1 over f is equal to 1 over 20. So let me do this one this way. So I'm going to have, since 1 over f is equal to 1 over 20, f is equal to 20. Just take the reciprocal of this. And hence, we can now calculate the radius of curvature. The radius of curvature, r, is equal to 2f, which is equal to 2 times 20, which is equal to 40 cm. You need to take note of all the signs and conventions that are used. So here you can see that I remember that because it's a virtual image, this must be minus 20. And finally, the C part of the question, it said if the image is virtual, what type of mirror is used? I think I've already answered that from the first part. So because the image is virtual and it is erect and magnified, then the type of mirror used is a concave mirror, or you can call it converging mirror.